Okay. I think we have did 2 to 3 questions. Am I right or not? How many questions we have attempt after the Gaussian property?
Yeah, but in my book, there's no questions.
No questions.
No, sir.
All right. Please note it down. Charge Q is placed a charge Q is placed at the center of hemisphere. Calculate flux through hemisphere. Okay. This is our question. And our hemisphere is given like this. This is our hemisphere. This is our hemisphere. Okay. A charge Q is placed at the center of hemisphere. Calculate the flux to hemisphere, right? This is our question. To calculate the flux, the one of the important point is that the surface, I think, should be closed. Okay. If you try to solve this question, first of all, we are going to close this hemisphere like this after joining one another hemisphere into it. And as we add one another hemisphere into it, okay, now it will become a sphere. Are you clear or not? So we can write here, add, 1 second. Yeah, add 5 more squares. Sorry, 5, add 1 more hemisphere. Okay. 1 more hemisphere. Now, the flux through sphere, is Q over epsilon naught. Then the flux through, we can write one sphere. We can write one sphere is equal to 2 hemisphere. Can we write it or not? Okay.
Yes, sir.
Flux through 2 hemisphere is equal to Q over epsilon. Okay. In this case, we can write here flux through 2 hemisphere. Now, then flux through 1 hemisphere is equal to Q over 2 epsilon. Are you understand it or not? Hello? Or if you
Yes, sir,
understanding
yes.
or not? Yeah. So the flux of 1 hemisphere will be Q over 2 epsilon, right? This is your final answer. Are you clear? Note it down, please. Okay, good. And I think there is Aisha, Akshay,
Done, sir.
Mansi, Nafia, and the next one. 1 second. Who is the next one? Rufia. All of you are understanding this question?
Yes, sir.
Yes, sir.
Okay, good. Have you noted it?
Yes, sir.
Right. Now we are going on the next question. Our next question is, a charge Q is placed a charge Q is placed at a separation a/2 from the center of square of each side A of each side A as shown in figure. Calculate flux through square. Note it down. And it is given that a surface of like this this is your surface, and it's saying that a charge is placed at a/2 separation at this position. This is your charge Q, which is separated by a/2. Okay. Your question is calculate the flux to the square, this square. Are you clear? Note it down first, then we will try to understand it in in detail. All of you have noted it? Hello?
Yes.
Yeah. And now, to solve this question, first of all, we are going to draw a cube, right? Why? Because we want to calculate the number of field lines especially. What is the means of flux? Flux in the sense number of field lines passing through this area. Okay. So if we draw it like this, then anyone can tell me how many faces are there in a cube? How many faces are there? I think there are total 6 faces. Am I right or not?
Yes, sir.
Yeah, there are total 6 faces. So what we have did right now, we have added 5 more faces, or you can say 5 more squares. All right. Then your flux through cube is equal to Q over epsilon naught. Hence, we can write here flux through 1 cube can be written as 6 squares. Can we write it or not? In one cube, how many squares are possible? There are total 6 squares. So we can write flux through 1 cube is equal to flux through 6 square, which is equal to Q over epsilon naught. Finally, flux through square is equal to 1 over 6 Q over epsilon. Are you understand or not? This is your final answer. This is the amount of flux passing through this given surface. Okay? Are you clear? Aisha, Akshay,
Yes,
Mansi,
sir.
Rufia, Nida. Is it clear or not?
Yes, sir.
Okay, good.
Yes, sir.
Note it down, please.
Done, sir.
Okay, all right, good. The another question which we are going to solve. Note it down. A right circular cylinder is placed with its center at the origin. And axis along positive x-axis. Calculate total flux through the cylinder and charge enclosed by the cylinder. Okay, this is your question. Note it down, please. Have you noted it?
Yes, sir.
Now, try to understand this question. It is saying that a right circular cylinder is placed with its center at the origin and axis along positive x-axis. Calculate the total flux through the cylinder and charge enclosed by the cylinder. Okay, this is your question. Now, we are taking a cylinder here. Let's consider that this is your cylinder. And in the question, it is saying that its center is placed at the origin. This means if we draw a coordinate system, then the center of the cylinder will be at the center of the coordinate system. Are you understand or not? Hello? All of you are understanding or not? This is your center
Yes,
of the
sir.
cylinder and which is placed at the origin of this coordinate system. This is your x-axis, I mean plus x-axis. This one is your plus y and this is your plus z-axis. Okay. Now, it is saying that calculate the total flux through the cylinder. To calculate the total flux, first of all, we should try to calculate the number of surfaces here. Can anyone tell me how many surfaces are here in this cylinder? Anyone?
3.
No. This is your surface 1. This is your of surface 2. And this is your of surface 3. Are you understand or not? I mean, there are two cross-sectional areas and one of them is the, and third one is the curved surface area. Okay. All right. And the next point, we can take it like the electric field, I mean, x is 0. I mean, when x is greater than 0, this is the region in which x is greater than 0. And in this region, x is less than 0. Are you clear? Are you clear or not?
Yes, sir.
Yeah. And the length of the cylinder is L. If the length of the cylinder is L, then what will be the length of the half cylinder? It will be L by 2. This one is the L by 2 and this also is L by 2. Okay. This is your L. This one is the L by 2 and this also L by 2. Okay. Now we are going to solve it. Flux through end 1. Flux through end 1. Right? This is your phi 1 can be, which is E dot S vector after expanding dot product, or I think there is no need to take the dot product here. Your electric field is given. This electric field will be E is equal to, suppose that it is your E naught I cap, and the direction of electric field in this region will be E naught minus of I cap. Okay, because this is in the negative x direction and it is your positive x direction. So in region first, this is your region first. The electric field line will passes so like this. Okay, this is your minus of I cap, and the radius of this Gaussian cylinder is small r. Finally, we can write the value of E is the electric field in the region 1 is E naught minus of I cap. And what is the cross-sectional area? Your cross-sectional area will be pi r square. And what is the direction of this cross-sectional area? This also lies in the minus x direction. So you should take as minus I cap. Finally, we got E naught pi r square. Minus I cap and minus I cap becomes 1. Okay. Similarly, what will be the value of flux through end 2? What will be the value of flux through end 2? This is your phi 2, which is equal to the E dot S. What is the value of E here? E is your E naught for region 2. This is your region 2. In this region, the value of E is E naught I cap. You can take it as it is. And the area vector, once again, it will be pi r square, and it is also I cap, positive I cap. Finally, after calculation, you get E naught pi r square. Similarly, for the flux, flux through curved surface area, or you can say curved area. Curved surface area. Your phi 3 is equal to E dot S. Now try to understand electric field in positive region. I mean in the region of x greater than 0 is along this direction. Whereas electric field in the direction of x is less than 0 along this direction. Whereas if the electric field line passes through this curved surface area, it is clear that it will go perpendicular to the field. I mean along this direction. Are you understand it or not? Hello?
Yes, sir.
All of you understanding or not? These are the direction of electric field lines passing through this curved surface area, which always be perpendicular to the surface, because it is a property of the electric field lines we have already studied in the property of electric field lines. Okay. And now can anyone tell me what will be the angle made by these electric field lines and the electric field vector? I think it will be, or you can also say,
90 degree.
this is your electric field passing through this here, or in another way you can say, suppose that if you are taking this area, so the area vector will be along the perpendicular direction also. Now we can say here this area vector makes 90-degree angle with the direction of electric field lines. We can write here ES cos of 90-degree, and cos 90 is 0. So finally we can write without any calculation. Sorry. Yeah. So we can write without any calculation. 1 second. Yeah. Phi 3 is equal to 0. Note it down, please. Note it down all of the 3 values of flux. All of you have understand it or not? Hello?
Yes.
Akshay, Nida, Aisha, Mansi, Rufia, all of you understanding?
Yes, sir.
Yes, sir.
Okay, good. Note it down, please.
Done, sir.
All right, good. And now, all of you have noted it. Hello, all of you have noted it. Mansi, Aisha, Mida, all of you have noted it or not?
Yes, sir.
Okay, good. And now we have value of phi 1 is 1 second, please. Give me a second. Yeah. And now, what is the total flux through this cylindrical surface? The total flux can be calculated as phi is equal to phi 1, phi 2 plus phi 3. What is your phi 1? Phi 1 is E naught pi r square. phi 2 is also E naught pi r square. Phi 3 is 0. Finally, you get the total flux through this cylindrical surface is 2 E naught pi r square. Note it down, please. Note it down, please. This is the total flux passing through this cylindrical surface. I think there is Hamza Shekhani.
Yes, sir.
Yeah, Hamza, actually we are doing a question on, okay, based on the electric flux today, okay? And after this question, we will start a new topic, all right? All right, Hamza?
Yes, sir.
Yeah, from that topic, you will, okay, understand completely, right?
Okay, sir.
Yeah, all of you have noted it? Akshay,
Yes, sir.
all of you have noted it? Nida?
Yes.
Okay, good. So it is a total flux passing. But in the question, it is saying that the amount of charge enclosed by the surface. It is also asking here. Okay. So what is the total charge enclosed? We can calculate it. 1 second. Yeah. Total charge enclosed, or you can also write charge enclosed. What is the charge enclosed? Charge enclosed can be calculated as Q is equal to, phi is equal to, 1 second. Yeah, phi is equal to Q over epsilon naught, or we can also write Q is equal to phi epsilon. What is your value of phi? Phi is 2 E naught pi r square epsilon naught. This is your total charge enclosed within this cylindrical surface. Are you clear? This is your next answer. Note it down. Can we move on?
Yes, sir.
Hello? Can we move on?
Yes, sir.
All right, good. Next one is application of Gauss law. This is our next heading. Application of Gauss law. For the application of Gauss law, some basic equation which we have already learned that I am going to writing here. Again, please note it down. Calculation of electric field due to symmetrical charge distribution. Integration of E dot ds Q over epsilon naught. I hope all of you have already remember this equation, which is from Gauss law. Do you remember or not? Okay. Next point, which is very, very important to remember here, we are going to understand about the criteria of the Gaussian surface. I mean, what are the conditions or what are the criteria where Gauss law can be applicable? Okay. So please note it down. Criteria to choose Gaussian surface, or sometimes you can also write Gaussian surface. Gaussian surface. What are the Gaussian surface? Note it down, please. We are going to understand criteria to choose Gaussian surface. The first of the criteria of Gaussian surface is your surface should be closed. Okay. I mean, Gaussian surface should be closed. Okay. Which is integration of E dot ds is equal to Q over epsilon. This is your criteria one. Okay. So can anyone tell me what is the first criteria? The first criteria is Gaussian surface should be closed. And what is your second criteria? The second criteria to use Gauss law is electric field is parallel or perpendicular to area vector. Remember here, electric field is either be parallel or perpendicular to the area vector. Okay. If electric field is parallel to the area vector, then the formula E dot ds will be E dot ds cos 0 degree, which is equal to Q over epsilon naught. And if it is perpendicular, then it will be E dot ds. When E and area vector are perpendicular, then the angle between E and area vector will be 90 degree. We are taking here cos 90 and value of cos 90 is 0. So the total value will be 0. The third point is electric field should be uniform. Electric field should be uniform throughout Gaussian surface. Throughout Gaussian surface. If it is uniform, then you can take E as a constant term. You can take it outside from your integral. Then the formula will be E integration of ds is equal to Q over epsilon naught. Okay. These are the three main criteria, I mean, which is very, very important type of criteria, okay, which all of you should remember at every time. Are you clear or not? Akshay?
Yes, sir.
Hello, Akshay, Rufia, Nida, all of you understanding these criteria of the Gauss law?
Yes, sir.
Yeah, these criteria tells us that when we can use the Gauss law, okay? I mean, what are the main conditions where the Gauss law is applicable? Are you clear or not? So the first criteria is Gaussian surface should be closed. I mean, your Gaussian surface like this, it is possible. It is also possible. This is also possible. But if the Gaussian, but if the surface is like this, then you can look here, it is open here. If your surface is open, then Gauss law is never, then you can't use Gauss law. Are you clear or not? I means that your Gaussian surface should be closed. All right. The second main point is electric field either be perpendicular or parallel to area vector. I mean, there is no any other angle is possible here instead of 0 and 90 degree. Are you clear? This is the second main condition. And the third main condition is that electric field should be uniform throughout Gaussian surface. If your electric field is not uniform, or you can say non-uniform, or you can say electric field is variable, in that case, Gauss law is not applicable. Are you clear? These three main conditions.
Yes, sir.
Yeah, good. Now we are going to understand the application of Gauss law. Okay. Next point. Type of Gaussian surface. How many types of Gaussian surface? Okay, we can take here, but remember that here. Just I am telling to you. First of all, please note it down. Types of Gaussian surface. Types of Gaussian surface. The first type is spherical. Second type is cylindrical. And the third type is cuboid. Cuboidal type of Gaussian surface is also known as Gaussian pillbox. Okay. Please note it down. Then I will try to, then I will describe it in detail. Mansi, are you understand it?
Yes, sir.
Any issue?
No, sir.
Rufia,
Yes, sir.
Aisha, are you understand?
Yes, sir.
Good. Note it down, please, all of you. Have you noted it? All of you have noted it or not?
Yes, sir.
Yeah. Try to understand here. These are the type of Gaussian surface, okay, which is mostly used in our syllabus. Remember that. This is a type of Gaussian surface which is mostly used in our syllabus, right? But remember that there is no any type of condition in the Gaussian surface, okay, that Gaussian surface should be like this or that, okay. According to the Gauss law, you can choose your own Gaussian surface according to your own convenience, okay. It doesn't matter which type of Gaussian surface you are choosing, but the matter is only and only that your Gaussian surface should be closed. Are you clear?
Yes, sir.
Are you clear or not? There is no any condition or rule in the Gauss law is that what is your Gaussian surface. Okay, you can choose any type of Gaussian surface according to your own convenience. Okay, but in generally we are taking the Gaussian surface according to the symmetry, because while taking the symmetry, while taking according to the symmetry, okay, the solution of the question becomes very easy. Are you clear or not? If the condition and if your question or your body and your Gaussian surface are not symmetrical, then your calculation becomes typical. Are you clear or not? So it is very, very important to remember here, always try to choose Gaussian surface symmetrical to the body. Are you clear or not? If you are doing like this, then your calculation will be very easy. Are you clear?
Yes, sir.
But remember that there is no any particular condition or any rule which tells you that Gaussian surface is like this or that. Okay, You can choose any type. You can choose like square, cube, okay, or this type also may be a Gaussian surface, which is okay. You can look this diagram. This is not a defined surface any, but it may also be a Gaussian surface. Okay, but remember that the only condition of the Gaussian surface is your Gaussian surface should be closed. If the surface is open, it never okay, it never be a Gaussian surface. Are you clear? And now we are taking an application on the Gaussian surface here, electric field. Due to infinite line charge or wire or rod. Okay, note it down, please. Electric field due to infinite line charge or wire or rod, you can also say. Note it down, please. Look at here. This is a body of, this is a type of body in length. Just 1 second, 1 second, sorry. 1 second. Please try to write one another concept before understanding it. Please note it down fast. Then we will try to solve it. Okay. Please note it down. Charge densities. This is one of the important point which I have left here. Charge densities. Okay. Please note it down. First one is linear charge density. Linear charge density, which is denoted by lambda. Note it down, please. Linear charge density, which is denoted by lambda. Okay. Note it down. Your charge is distributed in 1D element or in 1D body, like charge on the rod. Okay. Charge on the rod. Okay. Remember here, if the charge Q is uniformly distributed, on length L, then your formula will be lambda is equal to Q by L. This is your formula. In calculus form, you can write here lambda is equal to now. If you want to draw the diagram, then you can draw it like this. This is your line charge. This is your line charge of length L. Positive charges are given here. Okay. This is your line charge. Note it down, please. Sometimes it is also known as charge per unit length. Charge per unit length. This is also a definition of the linear charge density. Note it down, please. All of you noted it or not? This is your for uniform, and this can be applied for non-uniform and uniform as well. Uniform and non-uniform conditions. Note it down, please. Have you noted it?
Yes, sir.
Next one. Surface charge density. Okay. What is the definition? You can write here. Charge per unit area. Charge per unit area. Okay. And surface charge density is denoted by sigma. Sigma is Q over S. Okay. This is your surface charge density. You can also write sigma is equal to dq over ds. This is for uniform, and this equation can be used for uniform and non-uniform. Okay, i.e. you can write out. Okay, you can write also charge q is distributed on area S like this. Or just one second. Charge q is distributed in 2D element. Okay, two-dimensional element. Okay, like area. This one. This is a type of. Okay, this is a plate, and plate is a two-dimensional body. Okay, then the charge density of this plate can be calculated by the help of surface charge density. Are you clear? This plate may be a 2D, or you can also take a circular plate. Okay, this circular plate also an example of the 2D element. Are you clear or not?
Yes, sir.
Good. Note it down. Note it down first, please. Similarly, the next one is, have you noted it?
Yes, sir.
Similarly, the next one is volume charge density. What is the volume charge density? Definition is charge per unit volume. Charge per unit volume. This is your volume charge density. Okay. If it's your volume charge density, then your formula will be Q over V. Okay. Volume charge density is denoted by rho is equal to Q over V. This is used for uniform, and it will be dq over dV for uniform and non-uniform. Note it down, please. Such as you can take sphere, i.e. charge distributed on sphere. What is sphere? Sphere is a 3D body. Okay. Sphere is a 3D element, and you can take it like cube. What is cube? Cube is also a 3D element. Are you clear or not? So for 3D element, volume charge density is used. Note it down fast.
10, sir.
Good. All of you, Rufia, Nida, Mansi, Akshay, all of you have noted it or not?
Yes, sir.
Good. Now we are going back on the main heading, electric field due to infinite line charge. And now the charge given to this rod is positive in nature. And we are going to calculate electric field due to this line charge. Okay. Now anyone can tell me, can we use to calculate can we use electric field normal formula F is equal to QE or E is equal to F over Q to calculate electric field for this line charge or not? Anyone can tell me, please? This formula is applicable for not, applicable or not?
Yes, sir.
Hello,
Yes, sir.
Aisha, Akshay, can we use this formula to calculate it or not?
Yes, sir.
Why?
Because it's wire, like infinite line.
Rufia, Aisha, Mansi,
Not sure, sir.
Aisha, can we use this equation to calculate it? I think no. We can't use this formula.
Why, sir?
Why? This is the main question. Why? Okay. Remember that. What is this F? F is your Coulomb force. Do you know or not?
Okay, sir.
Do you remember or not?
Yes, sir.
This is your Coulomb force. And you have already know your Coulomb force is K Q1 Q2 over R square. Or sometime it can be also written as 1 over 4 pi epsilon naught Q1 Q2 over R square. Do you remember it or not? Tell me, please.
Yes, sir. Yes, sir.
Okay. And this formula is applicable only for point size charges. I mean, the charges which are infinitesimally small
Okay,
in
sir.
size. I mean,
Okay.
very, very small in size. Are you clear?
Yes, sir.
Yeah. So we can't use this formula, causing which we are using here Gauss law. Are you clear? Because
Okay, sir.
Gauss law, in Gauss law, there is no any criteria what is, okay, it doesn't matter what is the size and shape of the body. Are you clear? In the Gauss law, it doesn't matter what is your shape and size. Aisha tells the correct answer no. Okay. Yeah, there is no matter what is the configuration, you can say, or shape and size of the body. Are you clear? Gauss law can calculate electric field for nearly all of the type of bodies. Are you clear? So we are going to calculate it. Let's see here. This is your line charge, and we are going to draw the Gaussian surface first. What will be the shape of the Gaussian surface here? Any one of you? Yeah. Suppose that the length of this rod is L. Okay. This is your infinitely long, but we don't know what is the means of infinite here. Okay, we can't see the infinite here. We are considering a Gaussian surface. Okay, according to the symmetry. What will be the symmetry? Suppose that if we take a Gaussian surface in the cylindrical form, like this, we are choosing as a Gaussian surface this cylinder. Okay, and now what will be the direction of the electric field passing through is? This will be the direction, because your line charge is positive in nature. And if it is positive in nature, then we know the electric field lines will go outward. Are you clear? This will be the electric field lines. The length of the cylinder is, Gaussian surface is L. And how many surfaces are there in this Gaussian surface? There are total 3 surfaces. This is your surface 1. This is your surface 2. And this one is your surface 3. Are you clear? Hello?
Yes, sir.
All of you are understanding?
Yes, sir.
Good. And now we are going to calculate the flux. Then once again, we are going to use the same approach, just like the last question. Flux through N1. Or you can also say flux through surface 1. Okay. What will be the area vector for this surface? Anyone of you can tell me? What will be the area vector for this surface?
Yes, sir.
Sorry, what is the what is this area vector? This is your area, and your area vector always be perpendicular to the surface. This will be your area vector. Am I right or not?
Okay.
And this area vector makes 90 degree from your field lines. Okay. For the surface 2, your area vector will be once again perpendicular to the field lines, and it makes 90 degree. Similarly, if you draw the area vector for the curved surface area, I mean surface 3, it will be along the direction of the field. Are you understand? Then can anyone tell me what will be the flux for your surface 1? It is your phi 1 is equal to E dot S, which is equal to E dot S cos theta. Cos theta. What is your cos theta? What is your angle here? Theta. Value of theta for surface 1. This is your 90 degree. So we are taking here 90. We got 0. Any one of you have any issue in this equation? Sorry, in this solution?
No, sir.
No? Clear? Aisha? Rufia? Mansi? It is clear? Let's see for the surface 2. Now we are going to calculate flux through S2. I mean surface 2. This one surface. Phi 2 is E dot S, which is your ES cos of, what is the angle between the area vector and electric field lines? For surface 2, I am just asking to the Mansi. Mansi, can you tell me please? What will be the angle between E and S for surface 2?
90 degree.
90 degree, exactly. Good. We are taking again 90 degree. Once again, we get 0. Similarly, flux through surface 3. This is your phi 3. Flux through surface 3. What is your surface 3? Surface 3 is your curved surface. You can also write here curved surface. This is your phi 3. ES cos of, and now what is the angle? Just I am asking to Aisha. What is the angle for surface 3? Aisha? Hello. Aisha. Nida, what is the angle between E and S for surface 3? Hello? Yeah, Rufia. Rufia, what is the angle? Tell me, please. Look at here. This is your area vector. You can take it like unit vector or area vector also. This is your field line. Both are in the same direction. It is 0 degree. Okay?
Okay, sir.
We can write here E dot S, which is your phi 3. All right? And what is the S here? S is your area, I mean curved surface area of cylinder. Your curved surface area of cylinder is 2 pi RL. This is your phi 3. And now, what is the total flux? Note it down first, then we will calculate. Okay, the remaining part. Note it down first. Have you noted it?
Yes, sir.
Good. And now, what is the total flux? Total flux. This is your phi is equal to phi 1, phi 2, and phi 3. Phi 1, phi 2 is 0. Phi 3 is E into 2 pi RL. Okay. Finally, we can say here the total flux is E into 2 pi RL. This is your total flux. Are you clear? Now, we are going to calculate the field first. We are going to calculate the field. For the field, what is the relation between the, how can we calculate the field? For the field calculation, we have already know. One second. Calculation of field. Phi is equal to Q over epsilon naught. You can choose it like equation A, and this is your equation B. If you take from A and B, we can write here value of phi is Q over epsilon naught. So at the place of phi, we can write, sorry, one second. Put right here, put equation A. When you put equation A, I mean value of phi in the equation B, okay, you get E 2 pi RL is equal to Q over epsilon R. We have already know this is your okay linear charge density. So lambda is equal to Q over L, or Q is equal to lambda into L. You can put here, put Q is equal to lambda into L. Once again, E 2 pi RL is equal to lambda into L over epsilon naught. L is cancelled with L. Finally, E is equal to lambda over 2 pi epsilon naught R. Note it down, please. This is your value of electric field. Okay. This is your value of electric field due to the infinite line charge. Are you clear? Hello.
Yes, sir.
Hello. All of you are understanding or not? This equation is taken from linear charge density. Do you remember? All of you remember or not?
Yes, sir.
Good. Note it down, please. Note it down, please, fast.
Done, sir.
All of you have noted or not?
Yes, sir.
Aisha, Akshay, Hamza. Hamza, are you understanding?
Yes, sir.
Good. Mansi, Nida, all of you understanding or not? And now for this equation, one point is remaining here. This is your equation. E is equal to lambda over 2 pi epsilon naught. From this equation, we can also write E is directly proportional to 1 over R, or you can also say E is inversely proportional to R. If you want to draw the graph between E and R, then it will be, this is your E and R. Okay. This is your R, this is your E. Note it down, please. All of you have noted it or not?
Yes, sir.
Okay, good. Now it's over. We are taking a question here. Please note it down. We have two line charges. This is your first line charge. and this is your second line charge. Okay. The separation between these two line charges are A. Okay. There is a point in between these two line charges, which is your O and then I think the both of the line charges are separated by a distance from the center. Okay. In question, it is saying that calculate electric field at O. This is the question. This is our main question. Note it down, please. And now we are going to solve it. To solve this question, you should remember your last concept of the electric field lines, in which we have already studied that the electric field lines due to positive charge is always away from the charged particle, and due to negative charge, field lines is always towards the charge. All of you are remember or not? This concept, all of you are remember or not? Mansi, Nida, Aisha, all of you are remember this concept? Hello.
Yes, sir.
Okay. Now, anyone can tell me what will be the, suppose that the linear charge density of this is your lambda 1 and for this it is lambda 2. Any one of you can tell me what will be the direction of the field line at point O due to the positive charge plate. Due to the positive charge line. What will be the direction? I think the direction of the positive charge at O will be along this direction. Am I right or not?
Yes, sir.
Why? Because it always be away from the positive charge. And right here, E of plus. Okay. And for negative charge, your electric field lines will be towards the negative charge. This is your towards. This one is your E of minus. Then easily all of you can look at here. Both of the field lines are lying in the same directions, causing which we can write here the net field at O is E is equal to E plus of E minus. Your value of E plus is just we have already studied about the linear charge. This is your equation. This is your main equation. So we can write it like E is equal to lambda. For the first line charge, it will be lambda 1 over 2 pi epsilon naught. Separation from the center is A. Plus, and the direction is plus I cap. Similarly, for a negatively charged plate, the linear charge density is lambda 2 over 2 pi epsilon naught a. Direction is along plus x, I mean along I cap. Finally, after taking the common, in these two values, we get I cap over 2 pi epsilon naught a, and in bracket we can write here lambda 1 plus lambda 2. Note it down, please. All of you, please note it down. Any issue? Akshay, are you understanding? Akshay, Hamza,
Yes, sir.
Manshri,
Yes, sir.
Hamza, are you understanding?
Yes, sir.
Okay, good. Nida, Rufia,
Yes,
are you
sir.
understanding or not?
Sorry.
Okay, good. Note it down, please. It's over or not?
Done, sir.
Done. All of you, it is done or not? And now, next heading is electric field due to, 1 second. Electric field due to infinite plane sheet. This is your next heading. Electric field due to infinite plane sheet. All right. Hello.
Yes, sir.
Yeah, electric field due to infinite plane sheet. Okay. And about this heading, we will try to start. It is a very big solution. Okay. Electric field due to infinite plane sheet is also a big solution, which is very, very important from your examination point of view. Okay. And we will continue it in our next class, right? We are going over this class today right now.
Okay, sir.
Okay. Thank you. Bye-bye.
Thank you, sir.
Is there any issue? Feel free to ask me any questions. Okay, from this.
Okay, sir.